In 2012, a study was conducted in Western Australia collecting the spatial risk factors of Hendra virus in horses, caused by the large density of flying fox species. The Hendra virus is thought to be contracted in horses from eating recent matter that has been in direct contact with the flying fox, such as the urine, the saliva, or birth products. It is known that the ecological processes can have a huge influence on the spatial distribution and how the patterns of disease risk and disease incidents occur. Because of these spatial risk factors, it also has an effect on the geographical distribution of the pathogen, the natural host, and the potential spillover host, with the environment and the climate variables also having an effect on the behaviour. To be able to identify the spatial risk factors, the study used multiple analytical approaches to investigate the relationship between the plausible variables and the Hendra-infected horses. The analysis focused on Eastern Australia, including Queensland and New South Wales, as this is where most Hendra cases had occurred and been reported. Gathering the results, spatial data was taken from how many horses were infected, the controlled equine properties, the geographical occurrence of the flying foxes, and the environmental data. Also, spatial autocorrelation was used to identify spatial clustering and distances at which these were most prominent. And figures A and B shown here, these are the equine property locations and the Hendra hotspot spillovers. Figure A's results show the 1,189 controlled horse properties that had not had any reportings of Hendra between September 1994 and December 2012. It also shows the 40 reported cases of Hendra. With these results, it provided the case with a controlled ratio of 1 to 30. It also ensured the case properties were matched regardless of the variability of the property characteristics. In Figure B, it shows the hotspot areas with the most significant spillover clusterings along the central and northern coast of Eastern Australia. From the results of spillovers, it is evidence that the spatial clustering is formed at a distance of 40 kilometres. Using this information, the distance was used in a distance band shown in the Dieter's-Ord analysis shown here. As for the flying fox species, they had the most strongest positive correlation with reported Hendra cases. As for the environmental temperatures, both of the species of bats had negative correlations. Shown in this figure, a final prediction and residual values were mapped out to show the Hendra virus spillover on horse properties. Figure A shows the predicted spatial distribution of the flying foxes. Figure B shows the residual values suggesting that local risk factors can have a huge impact on Hendra transmission from flying foxes to horses. Analytic data regarding spatial distribution determined that spatial clustering was evident in infected horses. Furthermore, the study has shown that the density of the two closely related flying fox species to have a positive correlation on the equine case locations. It is important that future studies should be conducted so that unidentified risk factors can be identified.